Well, my name is Dr. Abdullahi, and inshallah, today I'll be discussing about some basic chemistry. So, the first thing over here is what is an atom? Atom is something that is electrically neutral in nature. What do you understand by neutral in nature? Well, neutral in nature means it has a positive charge, that is, it has a proton, and it has a negative charge, that is, it has electron. And if you see finally, if you see it over here, like atom contains some subatomic particles. Like example, atom has proton, which has a positive charge, and atom has electron, which has a negative charge. But they have same number of protons and electrons. So like it has same number of positive and same number of negative charge, and that is why you call it atom is electrically neutral in nature. Atoms are fundamental building blocks of all matter, and when they combine, they give you molecules. So the first thing over here, atom is the smallest particle. Atom is made up of some subatomic particles. Example, protons, which has a monopositive charge. It means it has +1 charge. It has electron, which has a negative charge, that is -1 charge. And it has neutrons, which does not have any charge. And atoms can combine to give you molecules. So atoms are neutral. They have equal number of protons, and protons are found in the nucleus, and they have equal number of electrons, and they are in a cloud of electrons. So at the center of an atom, what do you have? You have a nucleus, and nucleus contains protons and neutrons, and outside you have a cloud of electrons. So atom is electrically neutral. Why? Because it has same number of positive and same number of negative charges. So we move forward. Now you can see the figure over here. At the center, at the center over here, sorry, one second. At the center over here, you have a nucleus over here. So you have a nucleus over here, and inside the nucleus, if you see, you have two subatomic particles. One of them is neutron, and the second one is proton. And proton has a positive charge. And then you have a cloud of electrons, and they are in their shells. You have a cloud of electrons over here, and electrons, they have a negative charge. So they have, atom is electrically neutral because they have same number of protons and same number of electrons. They have same number of protons and same number of electrons. So electrons are one of the three types of subatomic particles, and the other two types are protons and neutrons. So you have three subatomic particles over there, mainly three. That is electron, which has a negative charge. Then you have protons, which has a positive charge. So electrons, they have a negative charge, protons have a positive charge, and neutrons, they don't have any charge. So electron is a negatively charged fundamental subatomic particles that makes up atoms. Electrons are fundamental particles that cannot be divided further into smaller particles. So electrons are subatomic particles that cannot be further subdivided. So again, another slide, you can see the same thing, approximately the same thing over here. Like you have a nucleus, and in the nucleus, what do you have? You have neutrons and you have protons inside the nucleus. And I've explained you before, like protons, they have a positive charge, and neutrons, they don't have any charges, and that is inside the nucleus. So you can say majority of the mass, a majority of the weight of an atom is concentrated inside the nucleus. So inside the nucleus, you have two things. You have protons and neutrons inside the nucleus, and majority of the weight is concentrated inside the nucleus. And outside the nucleus, you have a cloud of electron, which has negligible weight, you can say, but these electrons, they have negative charge. And these electrons are same. The number of electrons and protons are same. So protons has the same number and as electrons. Now we move on to the next slide over here. We are discussing about neutron. The neutron is also a subatomic particle with about the same mass as the proton, but it has no charge. Neutrons, they don't have any charge, but they have approximately the same weight as that of protons. Now we compare the three subatomic particles that we are discussing today. The first one over here is proton. The first one over here is proton, and proton, the symbol is P plus. You can see it over here, P plus. And what is the charge over here? It has +1 charge. Proton has a +1 charge. Then you have neutron. It has a symbol like N or this one because it has no charge. And it has no charge over here. And then you have finally you have electrons, which has a mono negative charge, or you can say it has -1 charge. So again, protons, they have a positive charge, or protons, they have a mono positive charge. Electrons, they have a mono negative charge. Now, till the time an atom is electrically neutral, it will be an atom. Now, atom, from the outside, from the shells, it can lose electron or it can gain electron. Atoms can lose electron or gain an electron. And when it loses an electron and when it gains an electron, it becomes an ion. It's no more an atom. Atom, because atom is electrically neutral in nature, and the moment it gets a positive charge or negative charge, it ceases to be an atom. It is not an atom because it gets a charge. And when it gets a charge, it becomes an ion. When it gets a charge, it becomes an ion. Now, the first thing over here, if you see, atom is electrically neutral in nature. You can see it over here. Atom is electrically neutral in nature. So you can see as a figure over here, you can see there are, say, like 3 plus charges over here, 3 positive charge, and you have 3 negative charge over here. So you have +3 and -3. So the net charge is 0. So the atom is electrically neutral in nature. Why? Because it has same number of positive and negative charge, or you can say it has same number of protons and same number of electrons. Now, if this atom loses an electron, you can say -e, it loses an electron. What happens? Now, before it has how many negative charges? It has 3 negative charges, or you can say it has 3 electrons. Now it has 2 electrons. But still, like, you have 3 positive charges. So when it loses an electron, it becomes an ion. Now it has a positive charge, and this is known as cation. So when an atom loses an electron, it becomes a cation. When an atom loses an electron, it becomes a cation. Now you can see it over here. How many plus charge over here? You have +3 charge over here. And how many minus charge you have over here? -2. So if you can see it over here, like this is +1. So the moment a neutral atom loses an electron, it becomes a cation. So the moment a neutral atom loses an electron, it becomes a cation. And now you can see the same thing over here in a different format. Now there is a gain of electron. Before we were discussing about the loss of electron, now we are discussing about the gain of electron. Now you have a neutral atom. How many plus charges are down there? 1, 2, 3. And how many negative charges are there? 1, 2, 3. So there are 3 positive charges, there are 3 negative charges, or you can say there are 3 protons and 3 electrons. Now this is a neutral atom because +3 -3, that is 0. It does not have any charges, so it's a neutral atom. Now it gains an electron. How many electrons are there? There are 3 electrons. Now it gets another electron. So 1, 2, 3, 4. And there is a development of an anion. So if it gains an electron, if an atom gains an electron, it becomes a negatively charged ion, or you can say anion. So we have discussed, like, when an atom loses or gains an electron, it gets a charge. It gets a positive or negative charge, and these are known as cations or anions. So you have 2 categories of ion. Now there is a third category of ion, which is known as Zwitter ion. There's a third category of ion, which is known as Zwitter ion. They have both the charges on the same molecule. So what do you have? You have both the charges on the same molecule, and the net charge is 0. So they have there is a cation, there is an anion, and there is zwitterion. Example, amino acids and the pH of the body at physiological pH. Amino acids, they exist as zwitterions. Amino acids, they exist as zwitterion at the physiological pH of the body, or at the pH of the body, which is approximately 7.4. So amino acids, they exist as zwitterion at the pH of the body. Now, you have a neutral atom. If it loses an electron, it becomes a positively charged cation. And you have a neutral atom. If it gains an electron, it becomes a negatively charged anion. So by losing an electron, it becomes a cation. By gaining an electron, it becomes an anion. And when it is neutral, it's an atom. So atom can lose an electron, or it can gain an electron, and it can become positively charged or negatively charged. Positively charged is known as cation, positively charged ion is known as cation, and negatively charged ion is known as anion. Now, just to understand this a bit more, why do you have this name anion and cation? You take an electrolyte chamber, and you take an electrolyte solution over here. Now, example, you have Na plus, that's an ion, and you have Cl minus, that's another ion. One has a positive charge and one has a negative charge. And you have two electrodes over here. One of them is connected to the negative end of the battery, and this is known as cathode. That is the negative charge over here. One of them is connected to the positive end of the battery, and you have a positive charge over here. Positive charge is known as anode, and negative charge is known as cathode. So you have cathode and anode. Now you have two things over here, two ions over here. One is Na plus and one is Cl minus. Na plus will go towards what? It will go towards cathode, or it will go towards anode. Cathode has a negative charge, so Na plus will go towards cathode. And that is why Na plus is known, it's going towards cathode. So it's known as a cation. It's known as a cation. Now Cl minus has a negative charge. Cl minus will go towards the positive charge. Positive charge is known as anode. So Cl minus will go towards the anode, and that is why it's known as a anion. It's known as a anion. So positive charges, they go towards the cathode, and that is why they are known as cation. Negative charges, they move towards the anode, and that is why they are known as anion. So it's like it's an easy way to understand or to memorize what are cations and what are anions. So cations, they go towards cathode, and that is why you take the first three words cat and ion, cation. So you have cations which goes towards the cathode, which moves towards the cathode, which migrates towards the cathode, and you have anions which move or migrates towards the anode. So you have An, and that's an ion, anion. Then, as I told you, there's a third category, you can say, of an ion. That's a zwitterion. They have both the molecules, both the charges on the same molecule. Example, amino acids. So we go ahead with amino acid over here. Like amino acid, they have a central carbon atom. Amino acids, they have a central carbon atom. So you can see it over here. There's an amino acid over here. There's a central carbon atom over here. One side is carboxylic group. Sorry, it's not the slide. Yes, this one. You can see the structure of an amino acid over here. At the center of an amino acid, there's a carbon atom. One side is carboxylic group. This is an acidic group, you can say. One side is amino group. That's a basic group, you can say. One side is hydrogen atom, and one side is R group. Now, this is the structure of an amino acid. There are different R groups, and that is why we have different amino acids. Now, you see this structure over here. It's one molecule. You see this structure over here. You have a negative charge over here. That is COO minus. You have a negative charge over here. And you have a positive charge over here. That is NH3 plus. So you have a positive charge over here, plus 1. You have a negative charge over here, minus 1. And the net charge is 0. These are known as Zwitter ions. So what are Zwitter ions? They have both the charges on the same molecule. Example, amino acid, they have the positive and the negative charge on the same molecule, and the net charge +1 -1 is 0. So they have both the charges on the same molecule and the net charge is 0. So these are amino acids and they can exist as Zwitter ion at physiological pH of the body. Now you can see it over here. Amino acids can have a negative charge. Sorry. Now you can see it over here. Amino acids can have a negative charge like COO minus. This is the fully deprotonated version of amino acid. You have a negative charge. And that's usually at high pH, and that's an anion. So amino acids can have a negative charge. Amino acids can have a positive charge. That's a cation. Amino acid can have a negative charge, or anion or amino acid can have a positive charge. That's a cation. And this is the fully protonated version. It is at low pH and at isoelectric point, IEP. This is known as isoelectric point. Amino acids, they have both the charges on the same molecule, plus and minus, and the net charge, you can say +1 -1, and the net charge is 0. This is a Zwitter ion. Amino acids exist as Zwitter ion at isoelectric point. That is, they have both the charges, plus and minus, on the same molecule, and the net charge is 0. So amino acids, they exist as Zwitter ion at isoelectric point. When they have both the charges on the same molecule and the net charge is 0, amino acid can exist as a negative charge. Amino acid can exist as a positive charge cation, and amino acids at the physiological pH of the body or at IEP, they can exist as a Zwitter ion. So amino acids, they exist as a Zwitter ion at isoelectric point. So what is isoelectric point? You can see it over here. It is the pH at which the amino acid or proteins carry both the positive and negative charges, and they form Zwitter ions. These ions are electrically neutral in nature. So they have both the charges, but they are electrically neutral. Like example, they have +1 and -1. So +1 and -1 will cancel each other and they will be neutral in nature. And that is why they do not move in the electric field, because they don't have a charge. They don't have any net charge. That is why they don't move in the electric field and they can be easily precipitated. They don't move in the electric field and they can be easily precipitated. Each amino acid has a specific isoelectric point. Now you can see it over here. This is IEP, isoelectric point. At isoelectric point, amino acid exists as a Zwitter ion. They have no net charges. And at an alkaline pH or high pH, amino acid is a deprotonated form. That is, it has a negative charge. And at a low pH, or you can say acidic pH, amino acid is fully protonated form. They have a positive charge. You can see there's a positive charge. So amino acid can exist as a protonated form. Amino acid can exist as a deprotonated form, and at isoelectric point, amino acid exists as a Zwitter ion. So amino acid can have a positive charge, amino acid can have a negative charge, and amino acid can exist as a Zwitter ion in which there is no net charge. Now, what's an atomic number? Atomic number of an atom. Atom, I told you, is electrically neutral in nature. But it has subatomic particles that have charges. Like example, proton has a positive charge, and electron has a negative charge. When both of them are same in numbers, like you have 10 protons and 10 electrons, so what will be the charge? 0. If you have, like take the case of sodium, it has atomic number 11. It has 11 protons and 11 electrons, so they cancel each other and the net charge is 0. So atomic number is the number of protons or electrons in a neutral atom. So the number of protons or electrons. So usually if I say the atomic number of chlorine is 17, it means it has 17 electrons and 17 protons. It means it has plus 17 charge and minus 17 charge. So plus 17 and minus 17 together, like if you see the atom is electrically neutral nature, so plus 17 minus 17, they will annul each other and the net charge will be 0. So atomic number is the number of protons or the number of electrons in an atom, and like example given over here is sodium, which has the atomic number of 11. So it has 11 electrons and 11 protons, and the net charge is 0 because atom, this is an atom, and atom is electrically neutral in nature. So you can see over here at the center there is a nucleus, and in the nucleus you have 11 protons. So they have plus 11 charge. It has 11 electrons also. Sodium has 11 electrons and the atomic number is 11, so it has 11 electrons. In the first shell, it has 2 electrons. In the second shell, it has 1, 2, 3, 4, 5, 6, 7, 8. In the second shell, it has 8 electrons. And in the third shell, it has 1 electron. So we can say there is an excess of 1 electron in sodium. There is an excess of 1 electron. Means there is zida, excess of 1 electron in the case of sodium. Now this excess electron is lost by sodium. So if there is a loss of electron, there is an empty valency shell over here. Now there is a loss of 1 electron. Before there were 11 electrons, now how many electrons are there? There are 10 electrons. But the proton is still the same. It's 11. Proton is 11 and the electrons are 10. So it has plus 11 and minus 10 charge. And what is the charge over here? Plus 1. So sodium is converted to an ion, that is Na plus, by the loss of 1 electron. So sodium has excess of 1 electron, it loses 1 electron and it becomes an ion, that is Na plus. So the same thing over here, you have 1 extra electron, an excess electron in the outermost shell. When it loses 1 electron, it becomes an ion, that is Na plus. It becomes an ion, that is Na plus. So this is the formation of a cation, or like when the neutral atom loses 1 electron, when the neutral atom loses an electron, it becomes a cation. So this is basically the formation of a cation by the removal of electron. Now the different thing, something different over here. What's happening over here? It's about chlorine. Chlorine has atomic number 17. What is the atomic number in chlorine? 17. It means it has 17 protons and 17 electrons. So you can see it over here. The first shell, how many electrons are there? Sorry. The first shell, how many electrons are there? There are 2 electrons in the first shell. Then the second shell, you have 1, 2, 3, 4, 5, 6, 7, and 8 electrons in the second shell. And then in the third shell, you have 1, 2, 3, 4, 5, 6, 7 electrons. It needs 8 electrons in the last shell, but it has 7 electrons. If it has 7 electrons, it means there is a deficiency of 1 electron. It has 7 electrons in the outermost shell. So it means there is a deficiency of 1 electron. If there is a deficiency of electrons, it gains 1 electron. When it gains 1 electron, it becomes Cl minus, or you can say it becomes an anion. So it gains 1 electron, it becomes an ion. Which type of ion? That is Cl minus, and Cl minus is known as an anion. So this is the formation of an anion. Now you can combine them together. Sodium has atomic number, sodium has atomic number how much? 11. Sodium has atomic number 11. It means it has 11 electrons and 11 protons. So number of electrons is 11. In the first shell, it has 2 electrons. In the second shell, it has 8 electrons. In the third shell, it has 1 electron. So we can say it has excess of 1 electron. So there is an excess of 1 electron over here. Chlorine, atomic number is 17. So 287. In the first shell, it has 2 electrons. In the second shell, it has 8 electrons. In the third shell, it has 7 electrons. And there is a deficiency of 1 electron over here. So what happens? There is a transfer of 1 electron from sodium to chlorine. There's a transfer of 1 electron from sodium to chlorine. What happens? This gets a positive charge, and this gets a negative charge. So now what's happening over here? There's a transfer of 1 electron from sodium to chlorine. Sodium gets a positive charge, chlorine gets a negative charge, and they become ions. There's an electrostatic force of attraction between a positive charge and a negative charge. So there is an electrostatic force of attraction between Na plus and Cl minus, and they form a bond. This is a bond between the ions. They form a bond which is known as an ionic bond. So there is an electrostatic force of attraction between Na plus and Cl minus, and they form a bond which is known as an ionic bond. So ionic bond are formed by the transfer of electron from one atom to another atom, thereby creating a positive and negative charge. And there is an electrostatic force of attraction, and they are attracted to each other, and they form a bond which is known as an ionic bond. So again, ionic bonds are formed by the transfer of electron from one atom to another atom. One atom gets a positive charge, the other atom gets a negative charge, and they form a bond which is known as an ionic bond. It is between the ions. Now, there is a thing which is known as electronegativity. Now, what is electronegativity? It is the tendency of an atom to attract a shared pair of electron in a covalent bond towards itself. This seems to be a bit confusing, but like it's very easy. Like I've explained to you about a bond that is ionic bond. In ionic bond, what happens? There is a transfer of electron from one atom to another atom, forming a positive and a negative ion, and they combine together or they join together, and there's a formation of an ionic bond. Now, if there is a deficiency of one electron in one atom, example A has a deficiency of one electron and B has a deficiency of one electron, what they will do? They will share these electrons. So the bonds that are formed by the sharing of electron, these bonds are known as covalent bond. So first you have ionic bond. Ionic bond is formed by the transfer of electron, and covalent bonds are formed by the sharing of electrons. You can have a single bond, you can have a double bond, you can have a triple bond, depending on the sharing of number of electrons. So covalent bonds are formed by the sharing of electrons. Now you can see it over here. Like just let me do this. You have A over here and you have B over here. Both of them, they have deficiency of electrons. So what they do, they share one electron from A over here and one electron from B over here. They are sharing electrons over here. Now what happens if the electronegativity of A is more, this pair of electron will move towards A. If the electronegativity of A is more, what will happen? They will move towards A. If the electronegativity of A is more, then they will move towards A. Now, electrons, they move towards A. The electron pair move towards A and it is away from B. Why is this happening? Because the electronegativity of A is more. So what's happening? It is pulling the electron pair towards itself. Now this electron pair is near A, it is away from B. So what will happen? It gets a partial negative charge, or you can say a delta negative charge over here. And the electron pair is away from B, so this gets a partial positive charge or delta positive charge. So then they form a partial ionic character. They get a partial ionic character because the electron pair, because the electronegativity of A is more. What happens? The electron pair shift towards A. And this electron pair shifts towards A, and that's the reason it gets a partial negative charge and that gets a partial positive charge. Now we can see some of the examples over here. Like there was a scientist by the name of Linus Pauling. He gave a scale of electronegativity. Linus Pauling was a scientist. He gave a scale of electronegativity, and halogens are there like fluorine, chlorine, bromine. all these halogens, they have very high electronegativity. The highest electronegativity is of fluorine, which is approximately 4. So now there was a thing like if the difference of electronegativity is more than 1.7, if the difference of electronegativity between say A and B is more than 1.7, then the electrons will be transferred and there will be a formation of an ionic bond. If the difference of electronegativity is less than 1.7, then the electrons will be shared. Then the electrons will be shared and there will be a formation of a covalent bond. So ionic bonds are formed by the transfer of electrons, and covalent bonds are formed by the sharing of electron. And if the difference of electronegativity between two atoms is more than 1.7, then there will be a transfer of electron, and transfer of electron means there will be a formation of an ionic bond. And if the difference of electronegativity is less than 1.7, then the electrons will be shared. It means there will be a formation of a covalent bond. So you can see the periodic table over here, and you can see fluorine over there, all the halogens over there. So you can see fluorine over here. It has the highest electronegativity, approximately 4. And then you have chlorine. These are the halogens, bromine. All of them, they have high electronegativity. Again, the same thing like fluorine, chlorine, bromine, all of them, they have, these are the group which is known as halogen, and they have high electronegativity, and these are the electronegativity for all the elements in the periodic table. As I told you, if it is more than 1.7, if the difference of electronegativity is more than 1.7, then that will be a ionic bond. If the difference of electronegativity is less than 1.7, that will be a covalent bond. So example of an ionic bond, the difference is more than 1.7 is between NaCl. They have the ionic bond. And then like example, I told you, if the difference of electronegativity is less than 1.7, there will be a formation of a covalent bond. So this is the polar covalent bond between HCl, and this is a non-polar covalent bond between Cl2. And these are the different some elements and their electronegative value over here. So you can see chlorine over here, it has 3.16. That's one of the halogens. Now we take one case example over here. Sodium, sorry, sodium, what is the electronegativity? It is 0.93. And chlorine, what is the electronegativity? It is 3.16. Now, what is the difference of electronegativity? So 3.16 minus 0.93, the answer is 2.23. This is more than 1.7. So naturally, if the difference of electronegativity is more than 1.7, then that will be a ionic bond. Like there will be a transfer of electron from one atom to another atom, and there will be a formation of cation and anion, and there will be a formation of an ionic bond. So if the difference of electronegativity is more than 1.7, that will be an ionic bond. And in the case of NaCl, the difference of electronegativity between Na and Cl is 2.23, which is more than 1.7. So naturally, there will be a formation of a ionic bond. The same thing over here, a different figure. I like the figure, that is why I've kept the figure over here. More than 1.7, ionic bond, and less than 1.7, it's a covalent bond. Now we start with water. Water molecule, how many hydrogen over there? There are 2 hydrogen and 1 oxygen. So H2O. This is the structure of a water molecule, that is H2O. Now you can see the structure over here. The atomic number of oxygen is 8. The atomic number of oxygen is 8. What do we understand about this? By this, atomic number of oxygen is 8. So in the first shell, they'll have 2 electrons, and in the second shell, there'll be 6 electrons. So in the first shell, what do you have? You have 2 electrons. In the second shell, you have 6 electrons. So oxygen is there, atomic number atomic number 8. The first shell, 2 electrons. The second shell, 1, 2, 3, 4, 5, and 6. Now it has 6 electrons. It should have 8. So it means there is a deficiency of 2 electrons. It means there is a deficiency of how many? 2 electrons. Now there are 2 hydrogens over here. Like in the case of water, you can see H2. So there are 2 hydrogens. Now this hydrogen shares 1 electron with oxygen, and this hydrogen shares 1 electron with this hydrogen. Now you can see there is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons. So what do you have? You have H2O. Both of them, they share 1 electron with oxygen. And finally, they have a complete structure. You can see the molecule of water over here. Water molecule consists of 2 hydrogen atoms covalently bonded to an oxygen atom. Atomic number of oxygen is 8. The first energy level contains 2 electrons. So in the first shell, you have 2 electrons. And in the second energy level, it contains 6 electrons. And to be stable, it must contain 8 electrons. Due to the need of oxygen to gain 2 additional electrons, it gains them from 2 hydrogens, where each one shares its 1 electron with oxygen. So this is the way, like you have in the first shell, atomic number of oxygen is how much? 8. In the first shell, you have 2. In the second shell, you have 6. 6 means there is a deficiency of 2 electrons. 1 electron is shared by 1 hydrogen. The 1 electron is shared by 1 hydrogen. And together, they have 8 electrons now. So that is how they make up the octet. And this is how the water molecule is formed. Now you can see it over here. Oxygen, the value of electronegativity is high as compared to hydrogen. Oxygen has more electronegativity than hydrogen. So what will happen? Like example, they are sharing the electrons in the middle. They are sharing the electrons in the middle because oxygen has more electronegativity. Because oxygen has more electronegativity. So what will happen? Oxygen has more electronegativity. So what will happen? These shared electron pair, they come closer to oxygen. These shared electron pair, they come closer to oxygen and away from hydrogen. Because they are close to oxygen, so it gets a partial negative charge. It gets a partial negative charge. Because they are away from hydrogen, hydrogen gets a partial positive charge and partial positive charge. Now there is an electrostatic force of attraction between partially negative oxygen and partially positive hydrogen, and this is the formation of a hydrogen bond. So one side you have negative end and one side you have positive end, and that is why it's considered to be like water is considered to be a dipole moment, while water is actually a dipole. So oxygen is more electronegative than hydrogen. The shared electron in the bonded pairs will be more pulled by the oxygen atom. So the oxygen atom attracts or pulls the shared pair of electron in a covalent bond towards itself. So what will happen? This creates a partial negative charge on the oxygen atom. So there is a partial negative charge on oxygen atom and a partial positive charge on the hydrogen atom, and there is a partial positive charge on hydrogen atom. There are differences in electronegativity between oxygen and hydrogen. The water molecule actually has a dipole, and if you see the bond angle over here between HOH, the bond angle is 104.5 degrees. So between HOH, the bond angle is 104.5, and oxygen is slightly or partially negative, and hydrogen is slightly or partially positive, and that creates a sort of a dipole over here. There's negative and positive over here, and water molecule, the bond angle is HOH is 104.5. In the water molecule, oxygen has an electronegativity of approximately 3.44, while hydrogen has an electronegativity of 2.20. So if you subtract 3.44, 2.20 from 3.44, you will get 1.24. This is the difference of electronegativity. It is less than 1.7. So they will share the electron, but they, like oxygen, will have a delta negative or partial negative charge, and hydrogen will have a delta positive or partial positive charge. Now, say example, you have molecule 1, sorry, example, you have molecule 1, 2, and 3. So example, you have molecule 1, this is H2O. Say you have molecule 2, and you have molecule 3 over here. Let's see the interactions between different water molecules. So water molecule 1, as I told you, H has a delta positive charge and O has a delta negative charge. So from 1 to 2, what's happening over here? There's hydrogen which has a delta positive charge. It aligns in a way that it binds with a delta negative of oxygen. So there is a formation of a hydrogen bond, you can say over here. And there is, you can say, there's an electrostatic force of attraction between partially positive hydrogen over there from the water molecule 1, and their partially negative oxygen from the another water molecule. And the same thing over here. If you see, compare 1 and 3, what's happening over here? There is a partial negative charge over here. There's a partial negative charge on the hydrogen of the third molecule, and they combine. So all these water molecules, they can combine together by the formation of hydrogen bonds. It's the same picture over here. You can have different water molecules that they are combining by hydrogen bonds, because there is a partial positive charge on hydrogen and partial negative charge on oxygen. They are combining with each other. Now, according to the interaction of water molecules are classified into, say, 3 categories. The first one, hydrophilic, then hydrophobic, then amphipathic. The hydrophilic, what do you understand by hydrophilic? They are water-loving molecules. What is hydrophilic? They are water-loving molecules. These form hydrogen bonds with water, so they can dissolve in water. They are ionic substances, example, NaCl or sodium chloride or glucose. Then the second one over here is hydrophobic. They are water-hating molecules. What is hydrophobic? They are water-hating molecules. They do not form hydrogen or ionic bonds with water. So they do not form hydrogen or ionic bonds with water. So they do not dissolve in water. So these hydrophobic, they hate water. They do not dissolve in water. They do not dissolve in water. They are non-ionic substances. Example, oils and fat. They do not dissolve in water. Example, if you have a bottle of water, say, I'll bring you some water over here. So example, there is a bottle of water. I add some salt over here, NaCl, and I stir this. What will happen? It will dissolve. It will dissolve. It's hydrophilic. And now in the same water, like I take a bottle of water and I put some oil over here, and I do like this, what will happen? It won't dissolve. Why? Because it is hydrophobic. So these oils and fats are hydrophobic in nature. Then you have a third thing over here, that is amphipathic molecules. Amphipathic molecules like phospholipids are there, or lipoproteins are there. One side is hydrophilic and one side is hydrophobic. So you have two sides. One of them is hydrophilic, one of them is hydrophobic. This sort of a molecule is known as amphipathic. So what is amphipathic? One side hydrophilic and one side hydrophobic. The example is lipoprotein and phospholipids. So one side hydrophilic, one side hydrophobic. What is that? Amphipathic molecules. What are hydrophilic? Water-loving molecules. What are hydrophobic? Water-hating molecules. And what is amphipathic? One side hydrophilic and one side hydrophobic. That is amphipathic. The example is lipoprotein and phospholipids. Like example, there is it's lipoprotein over here. Lipoprotein is basically a conjugate protein. Conjugate proteins means it is made up of two things. One is protein and the other one is lipid. So lipid plus protein gives you lipoprotein. Now this is one of the figures over here. Outside you have the proteins Then in the middle layer, you have two things over here. You have this one, that is free cholesterol. And you have the head and the tails over here. Hydrophobic tails are there. There is head over here. This is phospholipid. These heads are hydrophilic. These tails are hydrophobic. Though this is also amphipathic. This is phospholipid. So in the middle layer, what do you have? In the middle layer, you have free cholesterol and phospholipid. And then there is a core over here. There is a core over here. The core is hydrophobic. The core is hydrophobic. You can see there is a core over here. The core is hydrophobic. This is the core of lipoprotein. And if you see, like, these are TAG. These are TAG. What is TAG? Triacyl glycerol, TAG. Then you have something very similar to free cholesterol over here, and but they have a tail. What is this? This is cholesterol ester, or you call it CE. So this is one of the example of amphipathic. What is this? One side you have a hydrophilic group, and the other side you have a hydrophobic group, and one of the example is lipoprotein. Now we have, I have already discussed with you, we have the chemical bonds, and I have explained you if there is a transfer of electron from one atom to another atom, and there is a formation, of ions, cations and anions, and there is an electrostatic force of attraction, so there is a formation of ionic bond. When you have an electronegative difference of more than 1.7, then it's an ionic bond. And in the covalent bond, if the difference of electronegativity is less than 1.7, then it's a formation of a covalent bond. Covalent bonds are formed by the sharing of electron, and like it can be a single bond, it can be a double bond, and it can be a triple bond. So it is the bond which is formed by the sharing of pair of electrons between a non-metal atom, example oxygen and hydrogen in the case of water. You can have a single bond, you can have a double bond, or you can have a triple bond. So like example, between A and B, you have a single bond. Between C and D, you have a double bond over here. Between E and F, you have a triple bond. Then I've already discussed with you, but again, like we can do it again. So you have Na and you have Cl. So Na, what is the atomic number over here? 11. What is the atomic number over here? 17. This is 11. So in the first shell, you will have 2 electrons. Sorry. In the first shell, you have 2 electrons. In the first shell, you have 2 electrons. So these are the 2 electrons. In the second shell, you have 1, 2, 3, 4, 5, 6, 7, 8 electrons. In the third shell, you have 1 electron. It means there is an excess of 1 electron. And chlorine, what is the atomic number? 17. It means you have 17 electrons. So in the first shell, you have 2. In the second shell, you have 1, 2, 3, 4, 5, 6, 7, 8. And the third shell, you have 1, 2, 3, 4, 5, 6, and 7. So you can say there is a deficiency. There is a deficiency of 1 electron. And here, there is an excess of 1 electron. So what happens? There is a transfer of 1 electron from sodium to chlorine. There is a transfer of 1 electron from sodium to chlorine. And what happens? Chlorine gets an extra electron. It gets a negative charge. Sodium loses 1 electron. It gets a positive charge. Now there are charges. These are ions. You have a positive ion, you have a negative ion, and there is an electrostatic force of attraction between them, and they form a bond which is known as an ionic bond. So Na plus and Cl minus, they have electrostatic force of attraction. They form a bond which is known as an ionic bond. Now we have the secondary bonds, like example hydrogen, which takes place between the water molecules. I've explained you before. Water molecule H2O, oxygen has more electronegativity as compared to H. So what happens? The electron pair comes near the oxygen atom. The electron pair comes near the oxygen atom. Now what happens? It develops a partial negative charge, and it develops a partial positive charge. So example, you have the first molecule over here, you have the second molecule over here, you have H over here, which has a delta positive charge, and you have O over here, which has a delta negative charge. So they form a bond. And like there is a electrostatic force of attraction between a partially positive hydrogen atom and a partially negative oxygen atom, and they eventually form a bond, and that's known as a hydrogen bond. That's known as a hydrogen bond. So you can see it over here, electronegativity difference of more than 1.7 is likely to be an ionic bond, whereas if the difference of electronegativity is less than 1.7, it is likely to be a hydrogen bond. So less than 1.7, hydrogen bond, more than 1.7, ionic bond. Now what are acids? What are acids? Acids are something that gives you H plus ion in solution. H plus ion or hydronium ion in solution. So substances which give hydrogen ion or H plus ion in solution, they are known as acids. Now you can have a strong acid or you can have a weak acid. What is a strong acid? Strong acids are completely ionized or are completely dissociated. Strong acids are completely ionized or completely dissociated, and weak acids are not completely ionized or not completely dissociated. Weak acids are incompletely dissociated, or you can say not completely ionized. So one of the example of a strong acid is HCl. HCl is a strong acid, so it is completely dissociated, and that's why it's a strong acid. Example, you have HCl. HCl is dissociated or ionized into H plus and Cl minus. This HCl is completely dissociated. Why? Because it's a strong acid. Then you have another strong acid, that is sulfuric acid, H2SO4. H2SO4 is completely ionized or completely dissociated into H plus HSO4 minus ion. This is also a strong acid. Why? Because it is completely dissociated. Then you have a weak acid over here, that is CH3COOH. This is slightly dissociated, and that's why it's considered to be a weak acid. It is slightly dissociated, that is why it is considered to be a weak acid. So CH3COOH is dissociated or ionized into H plus CH3COO minus. Now, what is common in all of them? If you see these three things, like you can see CH3COH, it gives you H plus. You see H2SO4, it gives you H plus. You see HCl, it gives you H plus. So all the acids, they are strong acids or they are weak acids, they give you H plus ion in solution or hydrogen ion in solution. So strong acid or weak acid, they give you H plus ion in solution, and that's a definition of an acid. Acid is something that releases or that gives you H plus ion in solution. So we have seen the example of HCl, it gives you H plus ion plus Cl minus ion. You have seen the example of H2SO4, it gives you H plus ion plus HSO4 minus ion. You have seen the example of a weak acid, CH3COOH, it again gives you H plus ion. So all acids, they give you H plus ion. And the other definition of an acid, you can say, is they have a pH less than 7. 7 is considered to be a neutral pH. You have a scale, a pH scale 1 to 14, and 7 is considered to be a neutral pH. And those which have pH less than 7, they are considered to be acids. So acids, the other definition is they have pH which is less than 7. Now, what are bases or what are alkalis? The substances which give you OH minus ion. You can call it a hydroxide ion or the hydroxyl ion. In solutions, these are known as alkalis. And then like a strong alkali or weak alkali, it depends on the degree of dissociation or ionization. Example, NaOH and KOH, sodium hydroxide and potassium hydroxide, are completely dissociated. When they are completely dissociated, they are strong alkalis. NH4OH, ammonium hydroxide, it is slightly dissociated. So it's a weak alkali. Example, NaOH, it breaks down into Na plus plus OH minus. So you can see there's a release of hydroxide ion, OH minus. And this is a strong base, so it is completely dissociated into the corresponding ions. Then you have another strong base, that is potassium hydroxide. It is broken down or dissociated into K plus plus OH minus. So again, if you see OH minus, OH minus, like that's a definition of a base or alkali. Anything that gives you a hydroxide ion or a hydroxyl ion, that is OH minus, is considered to be a base, and KOH is a base that gives you K plus plus OH minus. So all of them, they release OH minus ion in solution. NH4OH, ammonium hydroxide, is a weak base. You can see it's a weak base. So it is not completely dissociated, but again, it is dissociated into OH minus ion. So all these bases, they give you hydroxide or hydroxyl ion. Then there are substances which are amphoteric in nature, or you can say they are amphoteric substances. What are these? Amphoteric substances are the substances which can act as an acid in certain media or as bases in other media. Example of amphoteric are proteins and amino acids. So they can react with an acid or they can react with a base. And they have the property, they can react both with an acid as well as a base, and they are proteins, and examples are proteins and amino acids. So these are the substances, amphoteric substances. These are the substances which act as an acid in certain media, or they can act as a base in certain media. Example are proteins and amino acids. Now, what is pH? pH is minus log the concentration of H plus ion. Minus log H plus ion. So you can say negative logarithm of hydrogen ion concentration. It measures the hydrogen ion concentration, that is H plus ion concentration. The high hydrogen ion concentration, the low pH, and the low hydrogen ion concentration means the high pH. Now, pH 7 is considered to be neutral. Less than 7, acidic. More than 7, alkali. So, like you have a scale of pH 7, that is distilled water, is considered to be neutral. Less than 7, acidic. More than 7, basic or alkaline. There are some examples over here. The most acidic fluid is the gastric juice. The pH approximately 1 to 2. The most alkaline fluid is the pancreatic juice, pH 8. Milk has a range of 6.6 to 6.9 pH. Urine has a pH of 6. Blood has a pH of 7.4 approximately, but the range is 7.37 to 7.43. Saliva and aqueous humor of the eye, they have a pH of 7.4. Now, what is the way of measuring the pH? You can do it by litmus paper, or you can do it by pH meter. In the case of litmus paper, there is a comparison of colors. In the case of pH meter, they measure the hydrogen ion concentration. Litmus paper method is less sensitive, less accurate, and this is more sensitive, that is pH meter. So you can see the papers over here. These are the litmus papers. And blue litmus paper turns red if the solution is acidic. Red litmus paper turns blue if the solution is basic. So you can see the chart over here of the different colors, and these are the litmus papers. And this is basically the pH meter. And that's actually the end of the presentation. Thank you so much. Jazakallah khair. And inshallah, I'll try to make more lectures before the midterm exams. Okay. Assalamu alaikum.